Hello, I'm Ali Can Ayanlar and welcome to Next Tech. Today I'm going to show you some of Turkey's latest military products that are looking to change warfare from the air. We're at the headquarters of one of Turkey's largest defense companies, TUSAŞ. This massive campus stretches over 4 million square meters. So come with me as I explore how the skies are about to see some new Turkish hardware. One of the biggest advances in aviation since the turn of the century has been the advent and integration of unmanned aircraft or drones into the military. And right here, we have the Turkish aerospace industry's latest drone, the Anka 3. And in just a moment, it's about to go out for its latest test. This drone's primary goal is reconnaissance, and for that, you need to fly under the radar. Soon, the most obvious characteristic in achieving that becomes apparent. This drone doesn't have a tail. One other new feature for the company is its turbofan engine. But the first military drones developed in the early stages of World War II didn't have engines. The United States produced the first remote-controlled aircraft called the radio plane OQ-2. In fact, before she became one of the most famous women in the world, Marilyn Monroe worked at the plant assembling these drones. Back on the airfield, it's all systems go. The Anka 3's wheels start rolling. Today's test is going to be the last before its maiden flight, so they're carrying out high-velocity taxiing. While one of the prototypes is out for a spin, I head back into the hangar to get a better look at Turkey's most advanced drone. Ömer Yıldız is an executive vice president of the company's unmanned air systems and tells me about some of the features that makes this drone so special.
We optimized our aircraft, this aircraft, to be less visible in the radar. So that's why we don't have the tails on this one. And taking out the tails makes the aircraft unstable, which in turn makes the control quite difficult.
Is stealth technology kind of the prime driver in how advanced a particular drone is? Is that what's driving the technology now?
That's one of the motivation that drives the technology over here. And so there are various ways of obtaining the stealth state capability. One is the adjusted geometry. If you have a nice geometry and if you don't reflect coming back the RF waves, then you maintain the low radar cross sections. Our first aim is to solve the geometry, then address the other problems afterwards. And solve geometry, solve the flight control problem first.
You're kind of seeing a morphing between drones that are beginning to resemble fighter jets. There seems to be more of a convergence in the appearance.
We're getting close to fighter jet, but our purpose on this aircraft is not to dogfight, for example. And this is optimized for air-to-ground ISR missions and air-to-ground missions and deep strike missions. So with this plane, we'll take over the air-to-ground missions of the F-16s, for example.
When developing a model such as Anka 3, how important is it that it can communicate, work with other models that are being developed on this campus?
So we are developing on this aircraft, Anka 3, on the heritage of the Anka 1 and Anka 2, actually. We're using a similar, some are the same, some similar avionic equipment, for example. We can fly both our three aircrafts, Anka 1, Aksungur and this one, from the same ground control stations. So this is one commonality. The second commonality, we also on Anka, for example, we can do the joint operation with the helicopter. This aircraft will also have the joint operation capabilities. And besides that, this aircraft will fly as a loyal wingman besides the Kaan Turkish fighter. And we have a smaller target drones. They have started as a target drone, but they will carry out some other missions as well, the Super Şimşeks. So together, all these airplanes can work, cooperate, and act like a swarm in the mission.
Talking about swarms, drones aren't the only aircraft that are being developed by TUSAŞ. The most recent addition to the rotorcraft class is the Attack 2 helicopter, and it's just recently made its first flight. At first glance, this helicopter is huge, much larger than its predecessor, the Attack 1. But now, the question is, how am I actually going to climb into the cockpit of this beast of a helicopter wearing loafers and jeans when I should be wearing a flight suit?
This is Türkiye's newest helicopter, the Attack 2. The heavy chopper has been in development since 2019, but it only took 2 years to go from the drawing board up into the air for its first test flights. Why the urgency? Because any ground commander knows that helicopters are crucial on the battlefield.
My men are surrounded by thousands of Somali militia. I need help now.
The Attack 2 is drawing comparisons to perhaps the most lethal and proven attack helicopter in the last quarter century. I asked the executive vice president of TUSAŞ's helicopter program, Mehmet Demiroğlu, about the extraordinary development process.
Your customer or the end user comes to us and say, hey, I need a helicopter, a platform that can do this, 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 this. So you add all those things and you make a design. It's driven by payload, it is driven by altitude, it is driven by the speed, it's driven by the protection. So all those things, when you add up, this is what comes out. This is an iterative process. So you cannot just hit your target in the first shot. You give a shot, which is, the first shot is behind us, and we evaluate, okay, this is what we achieved, we can do this, and we are gonna discuss with the end user, hey, is this what you want? You wanna go bigger? You wanna go smaller? You wanna change certain requirements? So this is what we are gonna do.
How much of a critical addition will the Attack 2 be for the Turkish Armed Forces?
The requirement from the field changing almost every year, every 5 years. The battlefield is a dynamic, living entity, I should say. So when you set a requirement, like 2 years ago, 5 years ago, it may not be the same today. So it's as I said, it's an iterative process.
Where do you see the biggest potential for developments in this project?
The biggest improvement area is electronic warfare and remote distance identification and weapons related to this system. You don't have to go into the hot areas, the battlefield. You can, if you can do this beyond the certain range, that will be fantastic from your point of view.
As an executive in Türkiye's defense industries, how the evolution of the country developing its own indigenous technology has played a role in the environment that we are in right now?
The geography that we are in requires that you have to have these platforms and you have to make it indigenously. And the reason is, when you look at our history, we have lots of embargoes from our allies and from countries that we are buying weapons. And once you cannot get what you need, then you are stuck. Your independence becomes questionable. You can't intervene. You can defend your borders. So these projects and programs, indigenous ones, gives the ability to do just that, protect your independence.
What's the main difference between this and the Anka 3? I'm not talking about sort of physical characteristics, in terms of maybe mission objectives.
Their mission is quite different. For example, the UAVs is expected to fly a long time and watch all the time, and then do the mission when time comes. For our case, it is just a short time. You just go, take care of your business and come back. They work in combination and they complete each other. And they are controlled and command centers communicates all of them at the same time. So it is not just like a one section or one unit does helicopter work and the other unit does controls the UAV part. No, they work all together and they talk to each other. That is also one of the beauty of doing these developments indigenously, because whether it is in TUSAŞ doing the platforms, UAVs, fixed wings and helicopters, whether the electronic warfare coming from Aselsan and other sister companies, we know that they need to talk to each other. They have to be integrated. So once you start from the design process, that they will do this, it will be much easier and much complete, I should say, to do this type of integration. And when you send any of the platforms to a mission, they can talk to, that they can talk to each other and you can change things.
And that's the key to Turkiye's air strategy, having multiple hardware options integrated together so they can complement each other under a single command. But a crucial aspect of that integration is also developing more of that technology here at home. Now, in an uncertain world where conflicts spring up without notice, where past defense deals are scrapped and sanctions arbitrarily placed, countries like Turkey need to rely more on themselves when it comes to national security and the hardware to defend it. Well, that's it for this edition of Next Tech. Thanks for joining us, and we'll see you next time.